Hello friends, and today we'll be doing algebra. Algebra is a very easy topic and you can expect around 2 to 3 questions from this topic each year in your CSAT paper. So let's go and cover this topic and ensure our those marks which come through this topic. So basically we'll divide it into 3 subtopics, or the agenda would be covering these 3 subtopics. One is the basic identities in algebra, the other would be a linear equation in equations in 1 and 2 variables, which is the most important topic of algebra, and thirdly we would do quadratic equation. There is also another topic called inequalities, which we would cover in some other video and not here. It's not a very important topic as far as our UPSC is concerned. So let's concentrate on these 3 topics as of now. Without wasting any more time, let's go to basic identities in algebra, right? So these are few basic formulae which we have to keep in mind. All of us know these formulas from very early in our education. From maybe class 6 onwards we start learning these formulas. So just to recollect, I have put all the important formulas which can be used in our CSAT exam here, right? The first formula is a plus b whole square. It would be equal to a square plus b square plus 2ab, right? Similarly, a minus b whole square, just replace b by minus b in this formula and you would get it becomes equal to a square plus b square minus 2ab. The another important formula which is used in lots of questions is a square minus b square, and it is equal to a minus b multiplied by a plus b. So this is the formula of a square minus b square. Then there is a plus b whole cube, which is equal to a cube plus b cube plus 3ab multiplied by a plus b, or it can again be reduced to this form, right? So just keep this formula in mind. The another formula is a cube plus b cube, which is equal to a plus b, a square minus ab plus b square. So this is the formula. And if you have to do a cube minus b cube, just replace b with minus b. So here you would get, so a minus b, right? Here you would get minus, right? Here when you put minus b, minus and minus would become plus, and minus b square would become b square only. So this would be the formula of a cube minus b cube, but let's keep a square plus b square as of now. Then a raised to power n into a raised to power n, we all know that it can be written as a raised to power m plus n. Similarly, a raised to power m divided by a raised to power n can be written as a raised to power m minus n. Now 8th is also an important result, which is a cube plus b cube plus c cube minus 3abc can be written as a plus b plus c multiplied by a square plus b square plus c square minus ab minus bc minus ca. This result in particular is used when we are given a condition that a plus b plus c is 0. If that condition is somehow given in question, then we will see that a cube plus b cube plus c cube would become equal to 3abc, right? I'll just write it. It would become, let me copy this. A cube plus b cube plus c cube is equal to 3abc if a plus b plus c is equal to 0. This result is particularly very important, and you might get a question from this result only, right? So these are generally the basic identities. You would not get a direct question barring from the 8th identity. The question from 8th identity can be, there can be 3 numbers such that this becomes true, right? And then you have to find a cube plus b cube plus c cube. You can directly use this result to find a cube plus b cube plus c cube in that case, right? So apart from that, you would not get any direct question from these identities. These identities might be used in some other questions, right? We'll have practice questions where these identities would be used in the assignment, right? So you would understand that where these identities are used, right? So now let's go to the next topic, which is linear equations in 1 and 2 and more variables, right? So what is an equation? An equation is one which has equality sign, right? There is a LHS, there is a RHS. Usually on an LHS we have some variables. On RHS there is some constants, right? So 3 is a constant and a is a variable. Similarly, x is a variable, 5 is a constant. Here x plus 3 is on the LHS and 3 on the RHS, right? Here 4x is on the LHS, 5 is on the RHS. So these are all these four are linear equation in single variable. You see, only x is the variable, but if we have two variables, for example x and y, here it is linear equation in two variables, and if we have three, it is linear equation in three variables, right? So the highest power of any variable, right, would be 1. We can see the highest power of any variable is 1. So if here it is x square, it is not a linear equation, right? So we would not be doing x square plus y plus z. We would be doing quadratic equation in single variable only. So let's do firstly linear equation in n variables, right? So this is basic linear equation. We don't need much more terminology as far as our CSAT is concerned. Nobody is going to ask definitions and all that stuff. There would be some application questions. So to solve linear equations in one variable, so for example, if we have this 4x is equal to 5, for this to solve, we can just write this implies x is equal to 5 by 4, right? So we get the value of variable. But if we have x plus y is equal to 4, can we solve it? No, we cannot, right? Because x is dependent on 5. So there can be a solution called 1 comma 3, right? Or there can be a solution which is 2 comma 2. All these satisfies this equation. So there is no solution from this single equation. So in general we can say to solve linear equation in one variable, we need one equation. To solve linear equation in two variables, we need two equations. And to solve linear equation in n variables, we need n variables. So let's start with one variable. If the equation is given x plus 3 is equal to 6 minus 9, we can easily find x is equal to minus 6. But here it's a two variable equation. We would need another equation to solve this equation, right? Otherwise, by solving this equation, I mean we should get a unique result, which is a single result. Here if you put y is equal to 2, what would you get as x? X can be 4 and y can be 2 to satisfy this, right? If x is 5, then y is 0, right? If x is 3, y would be what? 4, and so on. So there is no unique solution, right? So a single equation in two variables does not have unique solution. There can be infinite number of solutions for this equation, right? Now when we are talking about this, all of us know that this can be plotted on a graph as well. So let's see how can we plot it on a graph. So these are two axes. This is called x-axis, y-axis, right? And this is a x-axis, right? So any equation can be plotted this way, right? So all the points which lie on this line would satisfy that equation, right? So similarly there can be another line which is like this, right? So now these are two linear equations, right? This is equation number 1, and this is equation 2. Now we see that these two equations intersect on a point, right? This one, I'll just circle it. So this point is called the solution of the linear equation, right? So that's what we mean by solution of the linear equation. Simple, that's the solution of linear equation. So when we talk about solution of linear equation, when two lines intersect, there is this unique solution, right? Now imagine we have a line which is parallel to our equation 1 line, right? Something like this. Something like this. Let's call it equation 3, right? It's called equation 3. So do they ever intersect? Do equation 1 and equation 3 ever intersect? They won't, right? So they won't have any solution. Equation 1 and 2, they intersect at a point, so we'll say they have unique solution. Equation 1 and 3, they never intersect, so we say they have no solution. Now again, if we have a fifth equation which also is overlapping equation 1, right? So equation 1 and equation 5 are overlapping, then they have infinitely many solutions, right? So this is again equation 5, sorry, equation 4. So they have infinitely many solutions. So every point on equation 1 as well as equation 4 is a solution for this set of two equations. So we say they have infinite number of solutions. Now let's go to our theory, right? So when do we say that two equations have unique solution? When they intersect, right? And if we just write a general form of equation in two variables, it would be ax plus by plus c is equal to 0. So this is equation 1. Let's put a1, a2, so a1x, it would be b1y, and finally let's name it c1, right? Similarly, if we have another equation which is, let's say, a2, b2 and c2, right? If these are the two equations, then these two equations would have unique solution if and only if a1 by a2 is not equal to b1 by b2, not equal b1 by b2. If that's true, only then we will say that they have unique solution. So here equation 1 and 2 are having unique solution, which means that a1 by a2 is not equal to b1 by b2. That's the condition which has to be true so that they have unique solution. For no solution, what do you have to see? You have to see that a1 and you have to just see that a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. So they have to be parallel, right? These two lines have to be parallel, which means that their slope is equal. So slope is a concept which I do not, or the term which I don't want to use right now, because it's in coordinate geometry and we have not covered coordinate geometry till now. But nevertheless, I'll just tell you what does slope mean. So if these are the two lines, right, so you can just simplify the second equation to make it 12, right? So you see that the variable part is same for both the equations. If variable part is same and constant part is different, then we say that there is no solution. So let's take another example which is more complex. So let's say an equation plus 2y is equal to 15 is first equation. The second equation is something like 20x plus 40y is equal to 80. Let's say it's equal to 50 or whatever, is equal to 15 only. So when we see this, can we simplify this further? Yes, we can, definitely. We can take 20 common and we would get x plus 2y is equal to 15 by 20, right, which is equal to 3 by 4, right? So these two equations, this one and this one, they have similar variable part, right, but the constant part is different, hence they would have no solution. Now for infinite solutions, what do we see? Again, we just simplify the equations so that variable part, the common things are cut out and we get the equations in the simplest form. And what we see is two equations would be similar, right? Now if we take 2 common out of it, we would get x plus y is equal to 8, right? So these two equations are similar, hence they would have infinitely many solutions. So just simplify. How to check whether there is no solution or unique solution or infinite many solutions? Just simplify the equations so that the common part is cancelled out or the common part is transported to the constant side, and check for the variable part. If variable part is same, common part is not same, then there is no solution. If variable part as well as constant part is same, there are infinitely many solutions. If variable part is also different, then there is a unique solution. As simple as that. No need to just remember the common form and all these fancy stuff which we used to do in our class 6 or class 7. No need to do that. Now this is secondary. No, a question might or might not be there from this concept. The important thing which comes each year from this chapter is the word problem, right? So there is a word problem which would be given and you have to find the solution. So let's look into how to solve the word problem questions. So the problem, something like this, might appear in your CSAT exam, which says an investor buys a total of 360 shares. 360 shares of 2 stocks. So there are 2 stocks. Let's say the number of shares he buy of each stock is X and Y, right? So he buy X stocks of first share and Y stocks of second share. The price of one stock is 35 per share, while the price of another stock is 45 per share. The investor spent a total $15,000. Okay? How many shares of each stock did he buy? We have to find how many stocks of each stock did he buy. So let's say for first stock he buys X, second he buys Y, right? Now can we form equations? Yes, we definitely can. An investor buys a total of 360 shares of these 2 stocks. So there are only 2 stocks and sum of these 2 stocks are 360. X number of stocks of first type and Y number of stocks of second type. The price of one stock is 35. So let's say the price of first stock is 35. So the total money spent on first stock would be 35 into number of stocks, right, which is 35x. The total money spent on second stock is 45x, and the total money which he spent on both of these stocks is 15,000. So we'll add them and we'll write it 15,000. So now we have two variables, two equations, we can easily solve it. How to solve it? Reduce the equations to the minimum form. So here we take 5 common, we get 7x, 9x, and it becomes 3000. Now what do? We have to solve these two. How to solve it? For example, we multiply equation 1 with 7. What do we get? We get 7x plus 7y is equal to 2520. The second equation is 7x plus 9y is equal to 3000. Now if we subtract 2 from 1, right? Or if we subtract 1 from 2, what do we get? This 7x would cancel out. This 7x and this 7x would cancel out, and we would get is 9y minus 7y is equal to 480, which means 2y is equal to 480, y is equal to 240. Now we know x plus y is equal to 360, so x is equal to 120, and in this way we now know the number of stalks of both types. This is how we solve this equation. Once you do 3-4 questions, you would be very well versed with this method. Let's go to another question. Anthony has 32-cent stamp, some 29-cent stamp, and some 3-cent stamps. So he has 3 types of stamps. Let's say he has x number of stamps of 32 cents, y number of stamps of 29 cents, and z number of stamps of 3 cents. So as soon as you just read the first stamp, you introduce the variables. Now he is giving the relationship between these. The number of 29-cent stamps is 10 less than 32. So 32 are x, 29 are y. So y is 10 less than x. So y is equal to x minus 10. While the number of 3-cent stamp is 5 less than 29. So 3-cent stamp is z, and 29-cent stamp is y, and it's given that 3-cent stamp is 5 less than y. So y minus 5 is equal to z. Here we can also write z in terms of x by substituting y here. So z is equal to x minus 10 minus 5. So z is equal to x minus 15. What we are doing is we are writing each variable in terms of x. So y is in terms of x, z is in terms of x, x is already there. So we have found the relationship between y and x and z and x. Now finally he says the total value of stamp is $9.45, which means 945 cents. 32 into x plus 29 into y plus 3 into z is equal to 945. We know the relation. We can substitute y in terms of x, which we can substitute z in terms of x. In this way we can find x, which is equal to 20, we can find y, and we can find z. This is how we do it. Let's look at one more example and get going. It says sum of the digits of a 2-digit number is 7. When the digits are reversed, the number is decreased by 9. Find the number. So a 2-digit number is AB, 12, right? For example, 12. 12 can be written as 10 into 1 plus 2. A 2-digit number can be written as 10a plus b, right? So this you have to know even to solve this question. Now see, it says the sum of 2-digit number is 7. So a plus b is given to be 7. When the digits are reversed, the number decreases by 9. So AB when reversed becomes BA, and the difference between these two is 9. The number decreases by 9. Now let's write AB is equal to 10A plus B, BA is equal to 10B plus A. So we write it and it's equal to 9. What we get is A minus B is equal to 1. And now when we add 1 and 2, B gets cancelled and we get A is equal to 4. And b is equal to 3. So the number is 43. In this way we have to reduce the word equation into variables, then find the relationship between these variables, and write as many equations as there are number of variables, and thus solve the equations. It's very simple process, but you have to practice a lot, and there would be lots of practice questions in our assignment, so don't worry about it. These are the most basic questions, and these are the most important questions which you would encounter in your CSAT exam. Nothing beyond that. No need to understand the metrics and all that stuff which many fancy books talk about. So we'll restrict our linear equation in 1, 2 or 3 or 4 variables to this point only. Now let's do another topic, which is quadratic equations, right? So general form of quadratic equation is equal to ax square plus bx plus c is equal to 0. That's a quadratic equation. When we write y is equal to ax square plus bx plus c, it is a quadratic polynomial, right? So how does a quadratic polynomial looks like? Let's draw a quadratic equation. So it's a y-axis, here is x-axis. A quadratic equation would look something like this. Let me draw it. It's a parabola, so something like this. This is how a quadratic equation would look like. Now when we put y is equal to 0, it would cut x-axis at 2 points, right? These are the roots of this equation. Roots means the point where it cuts x-axis. So quadratic equation would have at max 2 roots, right? So these are roots of equation. Let's take another case, right? Can we draw a quadratic equation something like this? This is the one we draw earlier. Now this is also a quadratic equation, but it has only one root. So at max a quadratic equation can have 2 roots, but there can be one root as well. Or if something like this happens, there is no root at all, right? Because it never cuts x-axis, so there is no root at all. So 3 cases can be there. There can be 2 roots, there can be 1 root, or there cannot be any root. So let's see the theory about it. General form of quadratic equation is ax square plus bx plus c is equal to 0. Now we just simplify it. We divide it by a and we make it in the form such that we can write it in a square minus b square, right? So we define a term called discriminant d, which is equal to b square minus 4ac it would be equal to b square minus 4ac divided by square root of this is discriminant, right? So square root. This whole divided by 2a. This is the discriminant. Or I don't remember exactly, so it's, let's say, let's not talk about in terms of discriminant and all that stuff. Let's not give names to it. So there would be real roots. If we just look at this process, we'll find that the roots would be there if b square is greater than or equal to 4ac, and the roots would be minus b plus minus root of b square minus 4ac upon 2a. These would be the roots of the quadratic equation, right? If b square is less than 4ac, then we don't have roots or real roots of a quadratic equation. If we have b square is equal to 4ac, there would be only a single root of quadratic equation, which is written here. If b square is equal to 4ac, then both roots are equal and are equal to minus b by 2a. Otherwise, to get the 2 roots, this inequality has to be satisfied, that b square should be greater than 4ac. The another important thing which you have to keep in mind, or the important formulas, is sum of the roots. So sum of the roots of quadratic equation is b minus b by a. The product of the roots, so we have two roots, sum of those two roots would be minus b by a, product of those two roots would be c by a. Now before proceeding forward, let's see how to solve a quadratic equation. Let there be a quadratic equation, x square plus 11x plus 24 is equal to 0. Now we know that a is 1 here, right? So product of the roots would be 24 only, right? So 24 can be written as 6 into 4 or 8 into 3 or 24 into 1, right? Or 2 into 12 and so on, right? But here it should be equal to sum of the roots as well. So out of these, which would give us 11? So 8 plus 3 would give us 11. So we divide 11 into 8x plus 3x. From this we'll get x common, from this we'll get 3 common. Here from these two we'll get x plus 8 common and we'll get x plus 3, and our roots would be minus 3 and minus 8, right? In this way we solve the quadratic equation. We just divide the last constant term in such a way that sum of the factors become equal to this, right? That's how we do it. Had it been, let's do another example. Had it been this, something like this, what do we do? Firstly, we don't just now take 12, we take 12 into 2a as well, right, which is 24 again, and which again is equal to 8 into 3 to make it 11. We then write 8x plus 3x is equal to 12 is equal to this is equal to 0. Again from this 2x is common, so what we would get is 2x into x plus 4 plus 3 common, x plus 4 equal to 0. Now x plus 4 is common, and what we are left with is 2x plus 3. So if a is not equal to 1, we just multiply a and c and then take the factors, and then the procedure remains the same. This is how we solve a quadratic equation. This might come handy in solving few questions which might not be direct to solve the equation or find the roots, but which might be useful in another circumstances. Now let's go to some questions or some examples where we would use some of the properties which we have learnt before. So if a quadratic equation this is given has equal roots, find the value of k. So value b, so b is here 5, a is 1, c is equal to k. So b square should be greater than 4ac. So 25 should be greater than 4 into 1 into c. C is equal to k. So c is equal to k is equal to 25 by 4 is our answer. Now let's go to another question. In finding the sum of the roots, Anu made a mistake, and in finding the sum of the roots, which she calculated as 5, but she found the product of the roots right, which is equal to 6. Similarly, Arjun made a mistake in finding the product, but he calculated sum of roots to be correct and it is equal to 7. Find the roots. So Arjun has calculated the sum of roots correctly, which is 7, which means sum of roots is equal to 7. Product of roots would be 6. Now how to construct the equation? Equation would be x square. So we'll not write a, we'll assume a is equal to 1 to write the equation, plus minus of sum of roots into x plus product of roots should be equal to 0. This is how we reconstruct the equation. So the equation would become this: x square minus 7x plus 6 is equal to 0. So this is the equation. Now we write it. 6 can be written as 6 into 1. 6 plus 1 is equal to 7. So again we do it the same way we did it for the previous equations, and we find the roots of equations at 6 and 1. So this is how we solve this problem. This is a very common problem in CAT and in bank PO exams. This might appear in CSAT as well. Let's go to third example, which says an equation ax square plus bx plus 1, so c is 1, has real roots. So it's already given that it has real roots. What are the possible ordered pair of a and b if a and b can take value from 1, 2, 3, 4, 5? So for real roots, we know that b square should be greater than 4ac. C is 1, so b square should be equal to greater than equal to 4a, right? That condition has to be met. Now a can take value from 1, 2, 3, 4, 5. Now let's check when a is a, what can be the values of b. When a is a, b square should be greater than 4. When would b square be greater than 4? B can be 2, b can be 3, b can be 4, b can be 5. But if b is equal to 1, just put 1 here. Is 1 square greater than 4? No, 1 is not greater than 4. So b cannot be 1, but b can be equal to 2, 3, 4, 5. Now if a is equal to 2, it implies that b square should be greater than 8, which means that b can take 3, 4, 5. Similarly, a is equal to 3, b square should be greater than 12, which means b can be 4 and 5. A is equal to 4, b square should be greater than 16, which means b should be 4 and 5. A is equal to 5, b square should be greater than 20, which means b can only take 5. So how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 values of b are possible for different values of a. Hence there would be 12 ordered pairs. So this is all about theory of algebra. We have covered linear equations, we have covered quadratic equations, and we have covered some basic identities of algebra. That would be it as far as our algebra is concerned. There is a very small topic which is not a very important topic of inequalities, which we might do at the end if we have time, right? It's not a very important topic, and it's improbable to get questions from that topic. Most of the questions which you would get from algebra are from linear equations in two variables. There might be questions from quadratic equations, because quadratic equation is repeated in class 8 as well as in class 9, so there is a huge probability that there is questions from quadratic equations as well. So this completes our algebra as such. We don't need to devote too much time in learning various tricks and tips of algebra. We'll restrict our discussion to this point only, and we'll proceed to assignments on this, which would be sent to you very soon. So that's it for now. Thanks for watching this video. Hope you have understood the basic concept of algebra. All the best, and thank you once again.